product rule, again, we said before, if you have two functions here, if you add them or subtract them, the derivative of the combination of the two of them is the sum or the difference of the individual derivatives. But that is, again, not true for this. The derivative of a product is not just the product of the derivatives. Okay, it's not that. What it is it's the derivative of the first function times the other function plus the first function times the derivative of the second. Okay? 1 prime 2 times 1 times 2 prime 1. The derivative of each one times the other one. We're not going to right now try and get into proving why that is true, but I'll show you again the idea that we have here. If we go back to this, okay, if I change this now to the product of the two of them. Remember before, this is the sum of two functions, and you can see that the two slopes add up to this. And it's true if we had higher powers or any other kinds of function there. But if we change this now to, does it give me the little? Let's do this. Hard to use your keyboard upside down. Oh, and of course we need the. Did it work? Did it go? It didn't go. Yeah, I have to get my keyboard back to do that. There we go. Okay. So now obviously you're not going to be able to see the point up there, but maybe we can change the scale here a little bit, and we'll go to this, maybe to 2 there. Oops, I'm a little bit off. The slope of each one individually, if the rule that we said were true, so if this rule that I crossed out were true, then how would these be related here? This 4 is the slope of this, right? 4 is the slope of that. 12 is the slope of the other one at that particular point. If that other rule were true, if you come up with the slope of the product of two functions, this shouldn't be 80. It should be the product of those two numbers, right? 48, and it's not?
If you take the points from like C and D and just times their y, you get the V.
If you take the points from, if you times these two?
Yeah,
because this is the product of these two functions, right? So any of the y values for b is the one that's on this combined function. So you're absolutely right. These are the y values. These are the slopes of the curve. The y values are multiplied, right? Because you have a function, another function. This is just the product. So anywhere you go on there, those y values are going to be, even though you don't see this one here. Can I stop on there? Okay, 9, 27, 243. But the slopes are not. These two slopes don't multiply to give you this 80 here. All right. If we were to do the derivative of each and multiply it out, you would come up with the right thing there. Okay, you'd come up with what you expected there. What was the? Well, you can actually use this. You can actually use this information here to come up with what it would be using that rule. The rule says, let's go back to this now. Okay, this rule says you take the derivative of one times it by the other, and then you take the derivative of the other one times it by the first one, right? Derivative of the first times the second, and the first times the derivative of the second. If you, in fact, do that for those values, losing my marbles here. This one. If you do that for these values, so it says take the first function, take the derivative of the first function, which is this, 4, and times it by what? The value of, so the derivative of the first function there, which is 4. This is going to be better if I write it. You know what? Let's do that. Write it out so we can see it better here. We'll put a picture in here. Okay, I'll put a picture of this graph in here, and you can see how that rule works. we actually need the values as well as this. Maybe that's good. Okay, so we have that picture here. If you want the derivative of this combined thing, it's not just this times this. It's the derivative of, so if this was f and this was g, so this combined derivative should be f prime g plus f g prime. If you fill in those numbers, it actually works out to 80, which it should. If you take the two values, so if you take the derivative, f prime, 4, and you take the value of the function g, which was 8, I believe, right? 8, this value right there. 4 times 8, which is 32, of course. And you take the other one here, which is the value of the bottom function here, which is 4, this 4. This 8 right here. Okay, we have two things. We have the slope of this line. So we're talking about at this point. At this point, this line has a slope of, what does it say there? 12. This line has a slope of 4. This line has a slope of 80. We're trying to see how this is related. When we added the functions, it was just you add the two derivatives to get that. But this is not true here. What you have to do is you have to take the slope of 1, which is 4, times it by the y value of the other function, which happens to be 8. And then you take the derivative of the other one times the y value here. That is actually what works out to 80. All right, so it's a more complicated rule. You don't just multiply the two things. You don't just multiply the two derivatives. You take the derivative of one times the actual function, and you take the derivative of the other times the actual function. And similarly for if you have a quotient of two functions, so if this was like x squared plus 3x over 2x minus 5, you can come up with the derivative using this rule here. It is the derivative of the first one times the second minus the first one times the derivative of the second, all divided by the bottom function squared. Nice rule, eh? You could go through, you could draw, go back to the graph that we looked at and looked at individual values and see that it works out that way, right? Can I get rid of that? Come on. Now again, we're not going to spend a lot of time right now trying to prove these or anything like that. We just kind of verified it using some numbers on the graph that we just looked at. But I do want you to use these rules and see if you can apply them. The rest of this tutorial is some problems for you to do. Work through these problems using some of the rules you have there. There's a couple times you're going to have to use the product rule. I'm asking you to do it two different ways here. Quotient rule, a couple different ways. It gives you some little hints and things, hopefully, to help you go here. Then there's a couple of harder problems for you to do, but you have a good amount of time right now to work with that. So, and then once you happen to get through that, well, as you go, the answers are at the end of that tutorial. For this, I've put the answers in here for you to check wherever there's stuff that you need to work on your own. There's a few extra problems, just because I'm sure you're looking for extra problems to work on. But those are there if you want to do some of those. The answers are down below. And you can get started on the assignment if you have time at the end. The assignment for this unit, the assignment is sort of broken up into 4 parts, right? Or there's 4 different assignments, because it's too overwhelming if we leave it all till the end of this unit, because it's such a long unit. All right, can you get started on that? I can help you individually if you need help.